Hello students, now in this video also we will solve some examples on homogeneous recurrence relation, but now of order 3. So question is same one. Solve the recurrence relations. Solve the recurrence relations. Now, first one I will take. It will be, the relation is suppose AR equal to 6 AR minus 1 minus 11 AR minus 2 plus 6 AR minus 3 with A0 is equal to 2, A1 is equal to 5 and A2 is equal to 15. Okay. Now, solution. The given recurrence relation is it can be written as AR minus 6 AR minus 1 plus 11 AR minus 2 minus 6 AR minus 3 is equal to what? 0. So it will be a homogeneous recurrence relation. Now here K is equal to 3, so it gives us a cubic characteristic equation. Therefore, the characteristic equation is what does that? It will be alpha cube minus 6 alpha square plus 11 alpha minus 6 equal to what? 0. Now our aim to find the roots of this characteristic equation first. So now it is cubic one. So we are, first of all, we will apply trial and error method or the synthetic division method. So for that, we will assume this left hand side as a polynomial and we will substitute with the various values of alpha there. So now here let f of alpha equal to alpha cube minus 6 alpha square plus 11 alpha minus 6 equal to what? 0. We find a root by trial and error method. First root we will find by trial and error method. So for that, let me put first 1. So it will be 1 cube minus 6 into 1 square plus 11 into 1 minus 6 equal to what? 0. So that will be 1 minus 6 plus 11 minus 6. Sorry. Now look at it carefully. Here 1 plus 11 will be 12 and this is minus 12. So it will be 0. So 1 satisfies this equation, means what? 1 will be the root of it. So this gives alpha equal to 1 is one of the root, or the characteristic root we can say. So now as it is one of the root of this equation, so alpha minus 1 is a factor. Now we have to determine other roots. To determine other roots, we will apply a synthetic division method. Therefore, by synthetic division method, what we get here? You know, it will be as such. Here we will write the coefficients of this equation first. Here 1, minus 6, 11 and minus 6. Here this root 1 we will write here. Now this 1 as it is, we won't write anything here. This 1 into 1 will be 1, that one we will write. We have to add these, so it will be minus 5. Then again take product of these. So minus 5 into 1 will be minus 5. Again add them, it will be 6. 6 into 1, so we will write that part here. And this addition will be 0. If whatever number we will write here, if that is the root of the given one, then always we will get a 0 here. Otherwise it is not. Okay. So now from synthetic division, we will get, already we get one root here. So we get this one is these are the coefficients of our quadratic factor. Therefore, we get f of alpha, that is what this one, f of alpha is equal to 0. This f of alpha can be written as alpha minus 1. Alpha minus 1 is from this root, alpha is equal to 1, and this quadratic factor we will get here. This is the coefficient of alpha square minus this is the coefficient of alpha term, so alpha, and this is constant one, so plus 6, that is equal to what? 0. This f of alpha can be written as such. Now we can easily determine the factors of this quadratic one. So we will get here this alpha minus 1. Now here product should be 6, sum should be minus 5. So 2 and 3. So I get alpha minus 2, alpha minus 3 equal to what? 0. So as such we get the factors here. So hence the characteristic roots are now these are the factors. So this one equal to 0 gives 1, this one equal to 0 gives 2, and this one equal to 0 gives 3. Are what? 1, 2, 3, and that are real and distinct. That are real and what? Distinct. Now from that we will write the homogeneous solution. Therefore the homogeneous solution is what? Alpha AR, sorry, it is not alpha, it is AR H, that is equal to A1 1 raised to R plus A2 2 raised to R plus A3 3 raised to R. It will be as such. Fine. Now here this will be homogeneous solution. Now we are using initial conditions. So now this A0 is equal to 2 gives us A1 plus A2 plus A3 is equal to what? 2. A1 is equal to 5. So that gives us A1 plus 2A2 plus 3A3 is equal to what? 5. Now A2 is what? 15. So that gives us A1 plus R is 2 now. So it will be 4. 4A2 plus 9A3 is equal to what? 15. So this is our system. Let it be star. Okay. And this is our system. Suppose double star. Now this one we have to solve for finding A1, A2 and A3. Now this is a non-homogeneous system of linear equations. You had already learned this one in matrix algebra. So now you can use the rank row echelon form or the augmented matrix form to solve this one, or any other methods also, whatever you want you can use. You can use the Cramer's rule also here. Okay, but for that you have to reduce these one into two equations first. Later on you can use the Cramer's rule. Okay, so now let me use the augmented matrix method. So this one can be written as in matrix form 1 1 1 and augmented matrix, so 2. Again 1, 2, 3, 5, 1, 4, 9 and what? 15. Now let me reduce this one into row echelon form. So R2 minus R1 and R3 minus R1 I have to do. So R2 minus R1 and R3 minus R1 will gives me here, this R1 is as it is. Okay. So now this will become 0, 1, 2 and 3. Then again 0, 3, 8 and what? This will be 13. Now here I have to apply R3 minus what? 3 R2. So I will get here 1, 1, 1, 2 as it is. Now this R2 as it is. Okay. So this is 0, 3 minus 3, so 0 and 8 minus 6, so that will be 2 and 13 minus 9, so it will gives me 4. 13 minus 9, that gives me what? 4. So now this one can be written again in A1, A2, A3. So that will be A1 plus A2 plus A3 is equal to what? 2. A2 plus 2A3 is equal to 3 and 2A3 equal to 4. So now using backward substitution, now this one gives us A3 is equal to what? 2. Put up that A3 is equal to 2 here. This gives us A2 is equal to what? Minus 1. Now again these one we will substitute here. That gives A1 is equal to what? A1 equal to 1. So here we get the values of A1 is 1, A2 is minus 1, A3 is what? 2. Therefore our required solution is, hence the required solution is, what does that? It will be AR is equal to 1 into 1 raised to R, so it will be 1. Now minus 1 into 2 raised to R plus 2 into what? 3 raised to R. This is our required solution of this homogeneous recurrence relation. Now let us solve one more problem of same kind. Okay, let us see the next one so that you will be perfect in that one. Next, suppose second one. Question will be same. Solve the given recurrence relation. Now let it be, the equation is AR plus 3AR minus 1 plus 3AR minus 2 plus AR minus 3 equal to what? 0, with A0 is 1, A1 is minus 2 and A2 is what? Minus 1. So now solution. The given recurrence relation is, what does that? It is AR plus 3AR minus 1 plus 3AR minus 2 plus AR minus 3, that is equal to 0. Therefore the characteristic equation is. The characteristic equation is. What is the characteristic equation here? It will be alpha cube plus 3 alpha square plus 3 alpha plus 1 is equal to what? 0. Now again, if you look this carefully, it is nothing but alpha plus 1 cube equal to what? 0. So this gives alpha is equal to what? Minus 1, minus 1, minus 1. So are the repeated roots. Are the repeated roots. So as these are the repeated roots, therefore the homogeneous solution is, therefore the homogeneous solution is. What does that? It will be AR H, that is equal to A1 plus A2R plus A3 R square into minus 1 raised to what? R. Now we will use the initial conditions. So now what is with us? A0 is equal to what? 1. A0 1. So that gives us from here R is 0. So these two terms become 0. A1 into minus 1 raised to 0. Minus 1 raised to 0, that is also 1. So that gives A1 is equal to what? 1. Now A1 is equal to what? Minus 2. So that gives us here R is 1 now. So A1 plus A2 plus A3 here into minus 1 raised to 1 is equal to what? Minus 2. Minus 1 raised to 1 will be minus 1 and this is minus 2. So the minus of from both sides get cancelled. So A1 plus A2 plus A3 is equal to what? 2 here. Fine. And now next one, A2 is what? Minus 1. So that will be A1 plus 2A2 plus what? 4A3 into minus 1 raised to 2 equal to what? Minus 1. So that gives us A1 plus 2A2 plus 4A3 is equal to what? Minus 1. Plus 4A3 equal to minus 1. So now this is our new system. From these we get a new system. A1 is 1. So I can put up A1 here. If I put, call it as equation number 1 suppose. Let it be, this is star. Okay. This is 1. So this is A2 plus A3 is equal to what? I can put 1 here. So it will be 1. And here also 2A2 plus 4A3 is equal to what? Minus 2. The reason for these one from 1 I can see. For this step. The reason from 1. Okay. Now you can easily solve these one. So solving these two equations in A2 and A3. Solving these we get A2 is how what? A2 will be 3 and A3 is what? Minus 2. You can check that one. You can solve it simultaneously. Now once we get A1, A2 and A3, put up them in star, we get the required homogeneous solution. Therefore, the required homogeneous solution is what? AR is equal to, this is 1, plus A2 is what? 3. So 3R minus 2R square into minus 1 raised to what? R. This is our required solution here. As such, these problems can be solved. Now, let me give one problem as a homework to you. So, try for that. If you are unable to solve, ask me either on WhatsApp or on Google Classroom. Okay. So, now take that as a homework, and then we will stop for this video here. In next video, we will go for the particular solution for the particular, or in the sense for non-homogeneous recurrence relation when f of r is non-zero. So let me give homework of the same kind. The equation is, question is what? Solve the recurrence relation. Solve the recurrence relation, and the question is that the recurrence relation is AR minus 8 AR minus 1 plus 21 AR minus 2 minus 18 AR minus 3 is equal to 0 with A0 is 0, A1 is 2 and A3 is 30. Try to solve this. Okay. Now here we will stop. In next video we will see the non-homogeneous recurrence relation, how to solve them. Thank you.